So, welcome to Math with the Bakers. We're talking about equations in math and algebra. And I've got both of the girls here today, Erin and Brooke. And I thought what I would do is I would give them both a treat because they've been working so hard. Now we have a golden retriever named Hallie. You've seen her before in other videos. And I bought each of the girls a Hallie. So here's one for Erin. And I got you one too, Brooke. You ready for it?
That's how you push it down.
All right. So, what do you think? You've both been working hard and you both got a Hallie.
I've been working more than Brooke. Is that fair that she gets the bigger one?
So, yeah. Both girls have been working hard and they've got different size things. That's not fair. What should we have done to keep it fair, Brooke?
Had two same size things.
That's right. So in our equations, what we do for one thing, we have to do for the other thing. So if I was going to keep this equal, they would have got equal size dogs. So even though they're not equal size kids, they should have the equal size reward. So with the girls earlier, we saw that we needed to keep things equal. We needed to have the same size pieces of the dog toys. Stay Hallie. So if Hallie and I got on the teeter-totter, I weigh about 170 pounds. Hallie, do you know how much you weigh? Put up your hand if you know your answer. Hands up. High five. Oh, you do know the answer. You weigh about 68 pounds. So Mr. Baker weighs about 170. Hallie weighs about 68. What would happen if we got on the teeter-totter? Well, Mr. Baker would go down and Hallie would come up. Right? So it's all about being equal. So if I wanted these two chairs to be equal, and I got the dog to leave, look at that. What would happen now? Well, in order to keep it balanced, we'd have to take the same amount of weight off of this side. So I would have to remove 68 pounds too. So now we're going to look at some algebra equations and how that would work. So in algebra, we're going to be talking about solving equations. And just like the seesaw, where this guy is very big and this little baby is very small, they're not balanced. So these two people are not equal size. So just like a seesaw, a mathematical equation also has to be balanced. So an equation is a mathematical sentence that has two equal sides, separated by the equal sign. So I've made some balls. Over here I have 1, 2, 3, 3, and 1, 2, 3, 4, 4 balls. Equals, so there's that sign, 7. 1, 2, 3, 4, 5, 6, 7. So 7 balls over here, and 3 and 4 is 7. So both sides of this equation are equal. There's 7 on both sides. So when we've been talking about algebra, we were talking about variables. So remember that an unknown number in algebra is represented by a letter, and we call that letter a variable. So the same letter, let's say P for popcorn, the letter P could represent different numbers in different equations. So 2 plus P equals 3. In that case, the P would be 1. Or if it was 4 plus P equals 9, in that different equation, the P would be worth 5. So I drew a picture here to help us. 10 plus B equals 16. We call this an algebraic equation. And if I did it with a picture, over here I have 10, 10, and B, that mystery box. And on this side, it's equal. I have 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Both sides right now are balanced. But if I took these 10 balls off and gave them to my dog to have this variable alone, it wouldn't be in balance anymore. So by taking those 10 balls off and giving them to the dog, to keep things equal, I would need to remove 10 from this side. So I put a circle around it showing that I have removed those 10 balls. So here's my algebra expression, my equation, 10 plus B equals 16. There's the 10 balls I gave to Hallie, minus 10, they're gone. Over here, minus 10 to keep it equal. So over here, all that's left is B, and B is equal to 6. So I've solved the equation. I could go back and check that by saying 10 plus 6 equals 16. And that's true. And it works not just with adding or subtracting. It works with multiplying, dividing all the time. 14 minus p equals 6. So in order to get it to be whatever p was, right? P is equal to 14 take away 6, so p is equal to 8. Sometimes in algebra you'll see something like this, z over 6. And because on a computer you can't make that traditional division sign, this represents division. Z, the mystery, when you divide it by 6, the answer is 5. Since multiplication and division are inverse relationships, we'll do the opposite. So z equals 6 times 5, or z equals 30. So in algebra, the default operation is always multiplication. So if you don't see something else, like a division or an addition sign or a subtraction sign, you can assume it means multiply. So here, there's nothing else, just 6b side by side. Default means multiply. So 6 times b, the mystery number, equals 60. Now, addition and subtraction are inverses, like the opposite of each other. Division and multiplication, same situation. So I want this b all by itself. I just want the variable. So I'm going to divide by 6. Why 6? Well, there's 6 like mystery bags. So if I divide 6 mystery bags, 6 divided by 6 is 1, or 1b. Remember, what I do to that side, I need to do to the other side as well. So 60 divided by 6 is 10. So b is equal to 10. Sometimes it's pretty easy to find the missing number, but if we practice the algebraic way of solving questions, that's going to be pretty important because it'll also help us learn more complicated equations, two-step equations, combining like terms, things you'll do in grade 6, 7, 8, 9, 10, university. So here's an equation. 4 plus n equals 12. So I know it's an equation because it has an equal sign, and it has variable, and it has an operation, and it has some known numbers. So remember, equals, so this is going to be balanced. 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 over there. A big N, the mystery number, and 4. 1, 2, 3, 4. So what would I do if I wanted to figure out what this n is? Have it all by itself. Well, in order to have n all by itself, I'd have to take these 4 balls off and toss them in the trash can. Minus 4. Now if I just do that over here, but not over here, well then the balance will tip. This will end up way down low, and this would end up way down up in the air. So that's not cool. So over here, I'm going to take these 4, because if I took 4 over here, and throw them in the garbage can, gone, see you later. What does that leave us with? 1, 2, 3, 4, 5, 6, 7, 8. 8 over there, n over here, equals in the middle, so n equals 8. So I solved it using algebra. And that's what you're going to be working on this week.